Thank you for joining this lesson. That's Mathematics Paper 2, Section 2. Remember to subscribe. Remember to share. Remember to invite a friend. Yeah, you can click the share button so that you invite a friend to this live broadcast. So let me go direct to the section 2 of this paper. Our WhatsApp number is on the wall. You can refer. It's also our consultation line. Yeah, so this is the section 2 that we are going to discuss. We have been advised, according to the instructions, to answer any 5 questions in this section in the spaces provided. Now, for revision purposes, we shall attempt all the questions in the spaces provided. Number 17, 2 towns, A, 60 degrees north, 25 degrees in the west, and B, 60 degrees north, 155 degrees in the east, are both on the same parallel of latitude and also on the same great circle. A pilot can fly from A to B along the parallel of latitude or along the great circle over the North Pole. Part A, giving your answer to the nearest kilometer, determine which route is shorter and by how long. Take Earth's radius as 6,370 kilometers and pi as 22 out of 7. On the Earth's surface, allow me to begin by sketching the globe, which is the spherical Earth. This is our 0 degrees equator. This is a 0 degrees prime meridian. Now we are saying that A is to the west, that means to the left, 25 degrees to the west. So this is 25 degrees west, while B is 155 degrees in the east. 155 degrees in the east. Now they are both lying on the 60 degrees north. 60 degrees north. And this is an indication that you have 60 degrees north. Now this means with A here and B at this point, we can calculate distance first across the North Pole, whereby that is a great circle. Generally, when places are on the same, when they are on what we call supplementary longitudes, that is longitudes which are adding up to 180. For example, this one is 25 in the west and 155 in the east. The angle between them is 180, so they are supplementary. If we move from A to the North Pole, then down to B, we will be moving along the same path, and we will have traced the distance along a great circle. So along that particular great circle, we can calculate the distance. So assuming this is our equator, then for us to locate B, from the center of the earth, we are moving 60 degrees toward the north so that we may identify B. And also for A, it is 60 degrees at this point. We measure 60 degrees so that we may arrive at A. Now we want to move along the North Pole like that. So when we move along the North Pole, following 25 degrees west, when we arrive at the North Pole and we continue moving along the same path, we will automatically find ourselves along 155 degrees in the east. So it means for this particular path, now we can identify the angle at the center, which is 60, and we should know that the radius is that of a circle, that of the whole sphere. That is 6370 kilometers. So the distance along the North Pole in kilometers, along the North Pole, shall be determined by, because it is a great circle, being a great circle, theta over 360 2 pi r. Theta is the angle at the center of that arc, which is 60 degrees out of 360. The pi is already given, r, 6370. So we can now get the particular length as 6673 and a third kilometers. 6673 and a third kilometers. Now, if we move along the parallel of latitude, remember there are two options. The plane or a pilot can fly from A to B along the parallel latitude or along the great circle. We have begun with the great circle. Let's check the other option now, whereby the same pilot can also move along the parallel latitude. So along the parallel latitude, now we'll be moving such that from the center, we are moving all the way from 25 in the west, all the way to 155 in the east. That is to mean that the angle between the two places is going to be 180, because we are passing through the center. And with the center, which is this is the 0 degrees prime meridian, 25 to the west and the 155 to the east. So the angle difference between the two places now is going to exactly be 180. So we'll say distance in kilometers along the parallel latitude, or for the small circle, we call it a small circle. In kilometers, we need the distance to be theta over 360. Okay, we can even call it a different abbreviation for the angle, alpha over 360, 2 pi r cosine of the latitude where the two places are lying. Cosine of the latitude. Cosine of the latitude. So at this point now, we'll be talking about the angle difference, 180 divided by 360 multiplied by 2 multiplied by 22 over 7 multiplied by 6370, then cosine of 60, because the latitude where they are is latitude 60. And this particular distance is going to exactly be 10,010 kilometers. 10,010 kilometers. Remember, the main question here is determine which route is shorter and by how long. So the great circle, that is along the North Pole, is shorter by, we can check the difference in distance, 10,010 minus 6673 and a third. This is giving us a difference of 3336 and 2/3 kilometers, which means, again, for accuracy, we've been told giving your answer to the nearest kilometer. Therefore, we will not leave it as a fraction now. We have to say it is shorter by 37 kilometers, because 2/3 means 0.666. So we round it to the next kilometer, which is 37 kilometers. Part B. We also determining the average speed. Okay, the average speed of the aircraft is 600. Calculate to the nearest minute the time taken by the pilot using either routes. So along the Great Circle, the time, remember generally time is given by distance over distance out of speed. So time for that particular case is going to be 11 hours and 11 over 90. 11 and 11 over 90 minutes. Hours, sorry. These are hours. So those are fractions of hours. Hours, which means now we can make them minutes. And they are going to be 6, 6, 7, and a third, which is a 667 minutes, because we have to round it to the nearest minute. Yeah, to the nearest minute. Then along the parallel latitude, we have to take the distance as 10, 0, 10 over the same speed of 600. 10, 0, 10 over 600. And this will give us 16 hours and 41 over 60. 16 hours and 41 over 60. These are hours. Now, changed to minutes, we have to multiply them by 60. And this will give us 1001. Exactly 1001 minutes. So we have to convert to minutes that way. So that is how number one. That's how number one is supposed to be. The person saying that the screen is not clear, kindly check on your network. My screen is very clear. All right. We proceed to number 18, a question on three-dimensional geometry. ABCDV is a rectangular-based pyramid with AB 8 centimeters, just as you can see. BC equals to 6 centimeters. VA is equivalent to VB, equivalent to VC, equivalent to VD, and that is equal to 13 centimeters. So the slanting or the sloping edges are equivalent to 13 centimeters. Draw the net of the solid. So the first thing we're supposed to draw is the net. For us to come up with the net, we're just supposed to open up this figure and you will do a scale diagram. For my case, I'm just going to sketch it. So the net can be drawn by, first of all, drawing the base, which is rectangular, 6 by 8. 6 by 8. It's also good to label a net. In this case, we will have A, B, C, D. Now, after the base, we can draw the other parts, whereby they are the triangular faces now. The first triangular face can be ABV. ABV. So, we use 13 centimeters now. 13 centimeters. Remember, this is supposed to be, this is already 8 centimeters. So 13 centimeters. 13 centimeters. This is V. Then we do an equal triangle on the upper side, CDV. So again, using 13. Using 13. This would be V. So this is again 13 centimeters, 13 centimeters. Then from this point now, we can also draw the other triangular faces. The first one being ADV on my right. Okay, on the left, I can have ADV. Remember, I'm just giving a sketch. For your case, you're supposed to draw it accurately. So this is also 13. 13. But this side it's 6. So with again 6 centimeters here, we draw 13, so that we come up with a very good this is V. So 13 centimeters, 13 centimeters. We are having now we are having a sketch of the net. This is the expected net. Yeah. Calculate the height of the pyramid. Let's go to the diagram now. Calculate the height of the pyramid. Let me begin by getting the diagonal of the base, the diagonal AC. The diagonal AC, whereby being rectangular, the angle at B is right angled. So that angle being right angled, we need to take 8 squared plus 6 squared, the square root. This will give us exactly 10 centimeters. So from A to C, we have 10 centimeters. But again, we can drop a perpendicular height from the top to the base. From the top to the base. Perpendicular height from the top to the base. Now that is the height we want to calculate. Now, bringing the height to the base, it's dividing AC. Dividing AC. Therefore, we will say that this becomes 5 and this becomes 5. The height is unknown, but that angle being being a right angled triangle, then we can use 13 and 5 for us to get the angle, the side VO, the side VO. So we can say 13 squared minus 5 squared, the square root. 13 squared minus 5 squared, the square root, is going to give us exactly 12 centimeters. So the vertical height for that pyramid is 12 centimeters. We are also told that a line is drawn from B through the midpoints of BC and AD to V, back to V. Calculate the length of this line. So a line is drawn. Let me show you the line we are talking about. From V to the mid of BC, and again to the mid of AD, then back to C, back to V, then back to V, that way. That is the line in red, the one in red, the line that we are talking about. So with that line, then we can determine its length, because we just need to know the length, assuming this is N and this is M. Then we need to know length Vn, which is equivalent to Vm, So the length Vn will be, we can use 12 and half of Mn, which is 8. You know, Mn is just a translated AB. So it's 8 centimeters, which means O to N, we will have 4 centimeters there. So 4 centimeters and 12 centimeters, then we will get Vn. So 12 squared plus 4 squared, the square root. This is 12 squared plus 4 squared. So the square root of 160. The square root of 160, which means this is the square root This is the square root of, okay, I wanted to put it in sad form, but we can just carry out the square root. That will be 12.65. 12.65 centimeters. This is the length of, from the diagram, Vn. Vn, which is also Vm. Vn, which is also Vm. So with that length, now we will just say from V down to N, then across to M and up to V, it will be 12.65. We add the 8 centimeters, then we also add again 12.65. This is going to be 12.65, then we add 8. It's going to be 33.3 centimeters. 33.3 centimeters. That will be the length. Finally, on that particular question, now we are talking of determine the angle of the plane VBC and VAD. VBC, VAD. VBC, VAD. Let me even now clear the diagram so that you may see that particular plane. VBC, VAD. VBC is the plane here. Then VAD is also the plane on the other side. So the angle between these two planes now, the angle between those two planes is the angle at their mid. Yeah, you're now talking about the angle up here. That will be the angle between the two planes, because the two planes are meeting at a vertex V. So the angle between them will be the big angle here now, will be that angle. So for us to get that particular angle, we can just divide downwards here, such that assuming this is M and this is N, now we can talk of, this is O, we can use VON so that we get the angle at V and we multiply it by 2. So NVO, angle NVO. Remember, this is 4 and the angle at the side here is 12. So we have 4 and 12. So we can use tangent. The tangent of the angle theta here, small theta. The angle up there, the angle up there is going to be, we talk of the tan of theta equals to, the opposite length is 4 and the adjacent length is, so this is a third. So for us to get theta now, we need the tan inverse of a third. The particular angle will be shift tan a third is going to be 18.435. 18.435 degrees, which means now the bigger angle, the one we are interested in, the angle NVM, NVM is going to be 2 multiplied by 18.435, and this is going to be 36.87 degrees to 4 significant figures. So that is the angle that we are supposed to calculate. That is the angle we are supposed to calculate. Yeah, as we go to number 19, I want to wish success to the candidates of 2024 who are following up with this program. All the best. We are also reminding the continuing students of our programs over the holiday, which are going to take place in a Google meeting. Use the number on the screen to register for those particular classes. The deadline is 10th of November. So please make sure that you register for the same so that you may benefit and grow together with others. Number 19, a particle moves in a straight line and passes through a point Q when t equals to 0, but the velocity equals to 5 meters per second. It accelerates at the rate of a meters per second squared, given by the formula a equals to 6t plus 4 when t is time taken. When t is time taken. Part A, express the velocity of the particle at t seconds in terms of t. So for us to get velocity, we know that we are supposed to integrate acceleration. So we'll be integrating the acceleration function, which is a 6t plus 4 with respect to time. So when this one is integrated now, the power of t is supposed to increase. So t becomes squared and the new power divides everything. So instead of 6 now, we divide it by 3 so that we get 2. We divide 6t power 2 over 2. Then we add 4. T is introduced. The power is 1. So when you divide by 1, the effect is just the same. Plus c. Yeah, that is the integration. So v equals to that. We call it a infinite integration, whereby the limits are not known. But there is a condition given that when t is 0, the value of velocity equals to 5. So because of that condition, then we can get the constant here. When v equals to 5, t is 0. So instead of 6 over 2, remember we can have it as 3. Then time t squared plus 4t plus c. The value of c is equivalent now to 5, which means v equals to 3t squared plus 4t plus 5. This is now the particular specific velocity function. Another question, part B. What is the velocity at t equals to 3? Velocity at t equals to 3 now. We write it, but now the value of t is known. 4, 3, plus 5. When you compute this, you get the value of t as the value of v is 44 meters per second. 44 meters per second being velocity. Part C, calculate the distance covered between t equals to 1 and t equals to 4. For us to get distance, remember there is the velocity function. Velocity function equals to 3t squared plus 4t plus 5. Now we are supposed to integrate velocity with respect to time for us to get displacement s. We integrate v with respect to time. Therefore, the integral of 3t squared plus 4t plus 5 with respect to time. This is what now we are carrying out. So the integral now is going to be, and remember, it is now a definite integral. It's now definite, very definite integral. So from 1 all the way to 4, the distance in between there. Now we integrate 3t becomes 3t power 3 because it's already squared. The new power now has to divide so that t becomes power 3 plus 4t becomes now t squared, and the new power, which is 2, divides, so that we get 2 power t squared plus 5. T is introduced, plus a constant there for integration, 1 to 4. Then now we substitute 4 and 1. When we substitute 4, then it will be 4 power 3 plus 2, 4 squared, plus 5, 4, plus c. Then now minus, we substitute 1. 1 power 3 plus 2, 1 squared, plus 5, 1, plus c. Yeah, that is now the substitution. So that we talk of. In the first case, we're going to take to get a, let me even work it out using a calculator now. We are talking of a 4 power 3 plus 2 into 4 squared plus 5 into 4. Yeah. This is going to give us 116 plus c. Minus. On the other side, when we use 1, this will be 1 plus 2 plus 5, giving us 8 plus c. The constant, we call it arbitrary constant, it disappears. Then 116, when we subtract 8, we get 108. This one being distance, it will be meters. Distance in meters. And finally, find the acceleration when t equals to 2. Remember, acceleration function is given by 6t plus 4. So the value of acceleration will be 6 into 2 plus 4, and this gives us exactly 16 meters per second squared. 16 meters per second squared. Number 20. Number 20. This is a question on trigonometry. Actually, trigonometric waves, trigonometric graphs. Thank you so much for following. I can see you are still around. Thank you for following. Thank you for giving your comments. I really appreciate. Okay, number 20. Complete the table below for the functions y equals to the cosine of x and y equals to 2 multiplied by the cosine of x plus 30 for the range 0 to 360, the range of x. So we have the values of x given there. Then the first function is the cosine of x. Now, when we substitute for the cosine of x, this one is going to be direct. The cosine of 0, which is 1. The cosine of 30, 0.87. The cosine of 60, which is a 0.5. The cosine of 90, which is 0. The negative 0.5. Negative 0.87. Remember, these ones are being obtained from a calculator. So you just substitute them in a calculator, you get the values, and you continue. The cosine of 180 is negative 1. The cosine of 210 is negative 0.87. The cosine of 240 is negative 0.5. Then the cosine of 270 is 0. The cosine of 300, 0.5. The cosine of 330, 0.87. The cosine of 360 as a value equivalent to 1. Now in the other row, we are going to fill in 2 multiplied by the cosine of x plus 30. So for example, we start with x is 0. So 0 plus 30. We need the cosine of 30, then multiplied by 2. That will give us 1. The cosine of 30 multiplied by 2. That will give us a 1.73. 1.73. The cosine of 30 plus 30. So cosine of 60, then times 2. That will give us 1. The cosine of 60 plus 30. That's the cosine of 90 times 2. It just remains as 0. Then the next will be -1. The next is going to be -1.73. The next is going to be -2. At 180, we shall have -1.73. At 210, we shall have -1. At 240, we shall have 0. At 270, we shall have 1.0, or exactly 1. At 300, we shall have 1.73. At 330, we shall have 2. Then at 360, 1.73. 1.73. Then after you've filled the table like that, some other times they will give you instructions of fill the table below to 2 decimal places. In such cases, please ensure that you fill in 2 decimal places. Even if it's a whole number, like you get 1, just include 1.00. You get 0, write 0.00. Just obey instructions whenever they have been issued. On the same axis, draw the graph of y equals to the cosine of x, and also y equals to 2, the cosine of x plus 30, for the values of x ranging between 0 and 360. Yeah, and 360. So we need to come up with a very good scale which will accommodate all the values. In the first case, I will start with the intervals of 30 for the x-axis. Intervals of 30 for the x-axis. So we begin with a 0, then intervals of 30 now will flow 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So that is the scale for the x-axis. Now for the y-axis, I can see the largest value is 2. So I can use intervals of 0.5, 1.0, 1.5, 2.0, 0.5, negative now, 1.0, negative 1.5, negative 2.0. So that is the scale that I have chosen. I begin with the first curve. The first curve, let me use green for the coordinates. So I will start with the 0, 1, and then 30, 0.87, 0.87, 60, 0.5, 90, 0. then 120, negative 0.5, 150, negative 0.87, 180, negative 1, 210, we'll have negative 0.87. Yeah, that's how the coordinates are going to. At 300, at 330, you're having 0.87 at this point. Then finally at 360, we will have 1.00. So these are the coordinates plotted, and you can see that they are already suggesting a very smooth curve. So ours now is to come up with a smooth curve. Ours is to draw the smooth curve. So this is the first curve, which is y equals to the cosine of x. Let's look at the next curve, whereby we are also going to plot it. We're also going to plot it. Allow me use a different color again for the plotting of coordinates. At 0, I'm going to have 1.73, 1.67, so 73. At 30, I'm going to have 1. At 60, I'm going to have 0. At 90, I'm going to have negative 1. At 120, I'm going to have negative 1.73. Then at 150, negative 2. Then at 180 again, we'll be at this point. At 210, 1, negative. At 240, that is going to be 0. Then at 270, 1.0. At 300, 1.73, 1.73. At 330, I'm going to be having exactly 2. Then at 360, 1.73. So that's how the curve is. And this is what we are going to draw. This is what we shall draw. So I'm using a different ink for that purpose. So these are my two smooth curves on the same axis. And with the two smooth curves now, we can proceed to answer a few questions. Yeah, the other curve is here now. Y equals to 2 multiplied by the cosine of x plus 30. X plus 30. So these are the two curves decently plotted. But when I say you draw a curve, this is exactly what I expect from you. Now we go to the questions after the curve. The first question, state the amplitude of y equals to the cosine of x. Remember, amplitude is the highest a curve can go from the mean, so it's 1 for this particular curve. It's 1 because you can see the highest is a positive 1. It's just 1. State the period. The period of the graph y equal to the cosine of x plus 30. So a complete cycle for this particular graph, a complete cycle can be seen when we take let's say this. Let me give an example of what an amplitude, what a period is. A period, though physics students will understand this better, is when a wave makes a complete cycle. For example, when we consider the point here, the initial point, the wave has to move until it is at the same point again and moving in the same direction. Therefore, from this point, when we move until we are at this point, we will have made a complete period, and that is going to be 330. So it's going to be 330. 330. Mhm. So something you should understand again is that from this was 1.73. The topmost part on the other side is 2. So that is not the same position. So we are talking of when we study, let's say from 60, this is 60 degrees, all the way to 240. This is half a cycle. And within half a cycle, we are having a 240 from 60. This is 180 degrees, which means if this is for half a cycle, then a complete cycle will have to multiply this by 2 and we'll get 360. 360. This is from the graph, 360. Alternatively, this function can even be brought the way it is, and you are told to determine the period. Period should be determined even without plotting the graph, because we know the coefficient of x, when you take 360 out of the coefficient of x, which is 1 for this particular case, should give us the period. So the period is automatically 360, and also from the graph it is 360. Use your graph to solve. Cosine of x equals to 2, the cosine of x plus 30. You can see these are the two graphs which have been plotted. So we simply looking for the point where the two graphs are interacting. The points where the two graphs are interacting. And this is, let me read the values. These are the points. At that point, and also at this point, there are two possible points. Now, within 5 complete squares, 5 squares, there are 30 degrees. What about in one? To be 30 over 5, 6 degrees. Each small square is representing 6 degrees. If it's representing 6 degrees, then the value of x at this point will be 30. It will be 12. So 30 plus 12, 42. Also, x is going to be after 110, after 210, sorry, after 210, we are adding only one small square. So it will be 216, because one small square is 6 degrees, 216. That is That is it, 216. 216. Let's look at number 21 now. 21 is on rates of work and proportions. Rates of work and proportions, compound rates of work actually, and proportions, a topic in Form 3 mathematics. And we are supposed to take it very seriously. Supposed to take it very serious. Two tanks of equal volume are connected in such a way that one tank can be filled by pipe A in 1 hour 20 minutes. Pipe B can drain one tank in 3 hours 36 minutes, while on the other side now, pipe C can drain both tanks in 6 hours. Sorry, there is 6 there, in 6 hours. Calculate part A, the fraction of one tank that can be filled by pipe A in 1 hour. You know, we are saying that in 1 hour and 20 minutes, which means 1 hour and a third. You know, this can also be converted to 4 out of 3. In 4 out of 3 hours, pipe A can fill the whole fraction of the tank. What about in 1 hour? This means 1 times 1 multiplied by 1 times 1 divided by 4 over 3, which means times 3 over 4. So it is going to be 3 of 4 of the tank. 3 out of 4 of the tank. That is 4. This is for pipe A. This is the case of pipe A. In the second case, we are told to find the fraction of one tank that can be drained by both pipes B and C in 1 hour. Pipe B alone, we are saying B can drain one tank in 3 and 36 hours. 3 and 36 hours means 3, not that 6 can be converted to a fraction of an hour, which is 3. And this is a 3 over 5. Because when we take 36 over 60, yeah, it's 0.6, so 3 over 5. 3 over 5, which can be made a mixed number, and that will be 18 over 5. So 18 over 5 hours, it empties the whole, or it drains the whole fraction. What about in 1 hour? What fraction is going to be emptied? 1 by 1 divided by 18 over 5, which means times 5 over 18. So the fraction for B will be 5 out of 18 of the tank. 5 over 18 of the tank, or of one tank. The other one is C, whereby C alone can drain both tanks in 6 hours, which means because they are equal, then being drained in 6 hours, the two of them, one of them can be drained in 3 hours. So it means in 3 hours, pipe C now, pipe C is draining in 3 hours the whole fraction. What about in 1 hour? It's going to drain 1 by 1 divided by 3, which means times a third. So it's going to drain a third of the tank. Now, what we should ask ourselves is, what about when B and C are functioning together? So together, B and C, it will be a third and the other one is emptying 15 over 18 of the tank. Therefore, they will both empty 11 over 18. Yeah, 11 over 18 of the tank, or of a tank, of one tank, 11 out of 18. And remember, what we were solving is the fraction of one tank that can be drained by both B and C. So that is it. And finally, we are told pipe C, part C, pipe A closes automatically once both tanks are filled. Once both tanks are filled, assuming that initially both tanks are empty and all pipes are opened at once, calculate how long it takes before pipe A closes. So when we open all of them, we will have A. A is going to fill 3/4, but the other two are emptying 11 out of 18 per hour. So in 1 hour, the absolute fraction which will be filled, because there is A filling 3/4 and there is B and C emptying 11 over 18, then we will have 5 over 36 of the tank taking 1 hour. Taking 1 hour. So we will say 5 out of 36 of the tank is a fraction which takes 1 hour. What about the full fraction or the full tank? To be 1 by 1 divided by 5 out of 36, which means times 36 over 5. You know that 6 over 5 of an hour, that will be 7 and 1 over 5 hours. But now, this is one tank. So we would say for 2 tanks, it will be 2 multiplied now by the time taken to fill one tank, because there are 2 of them which are working. So this will be 14 and 2 over 5 hours. 14 and 2 over 5 hours. That is the time which will be taken for the tanks to be filled, the 2 of them, and that is when pipe A is going to close. That is when pipe A is going to close. Let's look at 22. 22. This is a question on commercial arithmetic. Thank you for being around. I can see you are seriously following. We are now on commercial. We are not talking about commercial arithmetic. That is on income tax. A topic which is very good and has a serious language which has to be understood. Serious language. The table below shows income tax rates, and we can see monthly income tax rates in Kenya shillings. There is also another column for tax rates in percentages in each Kenya shilling. Then now we are given further instructions that in 1 year, Mr. Kamau's monthly earnings was as follows: basic salary 20,000, house allowance 12,000, medical allowance 2,808, transport allowance 1,764. Calculate part 1, Mr. Kamau's taxable income. Taxable income is generally given by the basic salary plus all allowances, unless it is mentioned that some allowances are non-taxable. We assume that all of them should be subjected to tax. So I'm adding 20,000 the basic, 12,000 allowance, 2,808 allowance, 1,764 also allowance. So the total taxable income is supposed to be 36,572. Kenya shillings. So that is the taxable income for Mr. Kamau. The other thing is the tax charged on Mr. Kamau. When you look at the total taxable income for Mr. Kamau and you look at the table for taxation, you discover that the amount is not above 37,041. So we shall tax up to the fourth bracket, not all the brackets. From the first bracket, we are taxing 10,164. From the first bracket, 10,164 at the rate of 10%. This is going to be 1016.40 Kenya shillings. Then in the second, we're going to check the amount there, whereby we will take 19,740 and we subtract the limit of the other band there, 10,164. When you subtract there, you get 95.76. 95.76 at the rate of 15%. This is going to give us 1436.40. Now in the third band, we supposed to take 29,320 and we subtract 19,740. This is going to give us 95.80. 95.80 at the rate of 20%. Now these at the rate of 20% will give us 1916. 1916. Then finally, this is now the bracket where the last amount lies. So we need to take the total taxable income, 36,576, and we say 36,572, and we say we have taxed up to 29,320. So the remaining amount now is the one which lies in the fourth band, and this is going to be 72.52. So 72.52 now is the one to be taxed. 72.52 is the one to be taxed at the rate of 25%. So at the rate of 25%, we're going to get 1813.00. So now we can calculate what we call the gross tax, the total tax. When we add up now all the taxes and this is going to give us 6.80 Kenya shillings. Far, there are no informations about the relief, then we just underline that as our tax. Part B, Mr. Kamau was entitled to the following tax reliefs: monthly personal relief at a rate of 15% of the premium paid. So we can now calculate the relief already. 15% of the premiums paid. Then we are told that Mr. Kamau paid monthly premiums of 2500. This is going to give us 375. Yeah, 375. Therefore, at that point now we can talk of his net tax or other payee. The net tax, the payee that Kamau pays, the gross tax that we were having, now we less the relief that is given due to premiums. This is going to be 5806.80. 5806.80. Then we can now continue. Remember, the question is net salary. So for us to get net salary, we're supposed to take taxable income minus all deductions. minus all deductions. Taxable income is known to be 36,572. Then we subtract all deductions. The first deduction is payee. On any individual's income, the first deduction is usually the payee. Then other deductions. Now, other deductions are the things that he pays. He pays premiums. Now, premiums come in again as a deduction, and he also pays cooperative shares, 5,000. So at the end of the day, he's going to get 23,265.20 Kenya shillings. So that is the amount that Mr. Kamau gets at the end of the day. There is another interesting question, which is on sequences and series, number 23. A very good question, which I want us to go through. Remember, we are winding up. The second, third, and 14th terms of arithmetic progression are the three consecutive terms of a geometric progression. The 10th term of the arithmetic progression is 18. Find part A, the first term, and the common difference of the progression. Of course, now it is the arithmetic one, because arithmetic progression is the one that has a common difference. Anyway, for us to get nth term, there are a few things we are supposed to conclude. Nth term is generally given by the first term plus n minus 1 multiplied by d, which means the second term of an AP is A plus n is 2 minus 1. So just have plus d. The third term is going to be A plus, third means n is 3 minus 1, so 2d. Then there is a 14th term. So A plus 13d. These are the second, the third, and the 14th terms of a given AP. We are told they are three consecutive in a GP. You know, terms in a GP mean that there is a common ratio which multiplies all of them. If there is a common ratio that multiplies all of them, then we can just make a very simple conclusion here and say it means that when we take the term, which is the third here, when we take A plus 2D, then we divide by the first one, the first mentioned term, A plus D, we will get the same as when we take this third term, A plus 13D divided by the one up there, because they are consecutive. They are consecutive in a GP. They are not consecutive in the AP because they are second, third, and 14th. But when they are brought together now consecutively, they become a GP, which means there is a common ratio existing between the three terms. Now we can cross multiply and have A plus 2D multiplied by A plus 2D, which makes it just squared. Then A plus D multiplied by A plus 13D. Now we can expand and have A squared plus 4AD plus 4D squared. This is equal to, now on the right hand side, it will be A squared plus A by 13D, then D by A, that becomes 14AD, then plus 13D squared. Yeah, 13, the value of D squared. Now with this, we can group like terms together. You can see A squared and A squared cancelling out. Then we can have 10AD here, because 14 minus 10, 14 minus 4 AD. That will become 10 AD. Then on the other side, we will have a negative now. 4D squared minus 13D squared, it will be negative 9D squared. So we can see D is appearing on both sides. So this can be negative 9D equals to 10A. And the value of A can be written as negative 0.9D. Negative 0.9D. That is the first equation. Actually, this is equation 1. We can now interpret more information. The 10th term. The 10th term of an arithmetic progression is 18. 10th term is 18. So 18 equals to A plus 9D because it is 10th term. This is now our second equation. Now the two equations can be solved, whereby we know that the value of A is 0.9D. So 18 equals to negative 0.9, negative 0.9D plus 9D. Then this is going to be 8.9D. 18 equals to 8.1D. 8.1D. So that the value of D now becomes 2 and 2 over 9 when you divide 2 and 2 over 9. So that, substituting back now to this particular expression, we can get the value for A as negative 0.9 multiplied by 2 and 2 over 9. This is going to give us negative 2. So the value of A is negative 2. The value of D, the common difference, is 2 and 2 out of 9. 2 and 2 out of 9. The other demand is we find the sum of the first 10 terms. Sum of the first 10 terms. The first 10 terms of the AP. Now the AP, whereby we have found first term and common difference, we want sum of 10 terms. Generally, sum of a given number of terms is given by n out of 2 into 2a plus n minus 1 multiplied by d. This is one of the formulas. They can be several. So applying this now for the 10 terms, n is 10 over 2. Then 2 multiplied by a, which is negative 2, plus n minus 1. You know, n is 10. So minus 1, it becomes a, okay, let me write it even. Then d is 2 and 2 over 9. So this shall be 5 into negative 4 plus. This is going to be 20 over 9. You know, when written as a mixed number, as an improper fraction, 2 and 2 over 9 is 20 over 9. 20 over 9 times 9 becomes 20. So we'll be having now 16. 5 by 16 is equivalent to 80. Yeah, equivalent to 80. Alternatively, learners should know that we can even begin by getting the 10th term. The 10th term is going to be A, which is negative 2, plus 10 minus 1 multiplied by 2 and 2 over 9, we have said is 20 over 9. Therefore, this is going to be negative 2 plus 20, which is going to be 18. So the 10th term is 18. The 10th term being 18, now we can say sum of n terms equals to n over 2 into the first term plus the last term. of the progression. So this is going to be 10 over 2 into the first term, negative 2, plus the last term, that progression, being 18. So this is going to be 5, and inside the brackets, we will have 16. So we are having the same thing. The answer is going to be 80. Yeah, 5 by 16, which gives us 80. So the sixth term of the GP, that is part C, the sixth term of the GP, sixth term. We should know that for the GP, we need to get the first term, then we also get the second term. Remember, the terms are, the consecutive terms are this one: A plus D, A plus 2D, A plus 13D. The terms shall be A plus D, which is 20 over 9. This is going to be 2 over 9. Then the other one is negative 2 plus 2 multiplied by 20 over 9, giving us 2 and 4 out of 9. And we can also say that the third one is negative 2 plus 13 into 20 over 9. This is going to give us exactly 26 and 8 over 9. 26 and 8 out of 9. If these are the three terms, we can get what we are calling now the common ratio. R equals to, when we take this particular term, 2 and 4 over 9 divided by 2 over 9, this is going to be 11. The same can be confirmed by taking 26 and 8 over 9, 26 and 8 out of 9 divided by 2 and 4 over 9 confirms to be 11. So R for the particular GP is 11. If R is known, then nth term can be determined. We know that generally for a given GP, nth term is given by A, R, n minus 1. So the first term is 2 over 9 multiplied by R, 11. 11 now should be raised to 2. We need sixth term, so 6 minus 1. This is going to be 2 over 9 multiplied by 11 raised to 5. So I must confirm that using a calculator now. 11 power 5, then we multiply by 2 over 9. This is going to be 35,789. 35,789. Then 1 over 9. Fraction is 1 over 9. So this is the sixth term for the particular sequence. Then finally, now we got a question number 24, which is on a linear programming. Linear programming. So let's look at this now. We're going to interpret it together. I hope you are cooperating. So we finalize now. A certain uniform supplier is required to supply 2 types of shirts. One for girls labeled G, the other one for boys labeled B. The total number of shirts must not be more than 400. She asked to supply more of type G than of type B. However, the number of type G shirts must not be more than 300, and the number of type B shirts must not be less than 80. By taking X to be the number of type G and Y to be the number of type B shirts, write down in terms of X and Y all the inequalities representing the information above. So the information above is that, remember, for girls, we have X, and for boys, we'll be having Y. So we are saying for girls now, X type, the total number of shirts must not be more than 400. So when we take X and the other type Y and we add, it must not exceed 400. So it can be either 400 or below that. The highest it should go is 400. That becomes our first inequality according to that statement. Must not be more than 400. It means the sum can go up to 400, but should not surpass there. So 400 becomes the upper limit. She has to supply more of type G than of type B. She has to supply more of type G than of type B. Therefore, this one must be greater than this one. The number, it must be more. Again, however, the number of type G, this is X now, must not be more than 300. So X must not be more than 300. So can be 300, but not beyond that. Can be 300, but not beyond that. And type B must not be less than 80. Type B now must not be less than 80. Can be 80, but 80 is the least. So it should be more than that. Must not be less. So it's supposed to be greater than 80, but can also be 80. So these are now the inequalities already written. Part B. On the grid provided below, draw the inequalities and shade the unwanted regions. This is now what we're going to do as we wind up. As we wind up the inequalities, it's good to know that instead of inequalities, we plot what we call borderlines, whereby there is a straight line to represent each inequality. For example, from the first inequality, the borderline is going to be x plus y equals to 400. So we make a table of values for this inequality, for this borderline. So if x is 100, and when added to y, we should get 400, then this is supposed to be 300, then 200, this is supposed to be 200, because 200 plus 200 is 400. If this becomes 300, then y becomes 100. So that's a small table of values for x and y for the first inequality. Now for the next inequality, it should be x equals to y, the second borderline. This is the first borderline. The third borderline is going to be x being equal to 300. Being equal to 300. Then finally, y being equal to 80, the fourth borderline. So we have all the borderlines and we can now plot them. We have all the borderlines and we can plot them now on the grid provided. On the grid provided. So we have the y-axis and also the x-axis. And also the x-axis. Because we can see values which are even equal to 300, 400. So we can use intervals of 50, 0, 50, 100, 150, 200, 250, 300, 350, 400, 450. Then on the x-axis, we can also begin with the same 50, 100, 150, 200, 250, 300, 350, 400, 450, and such. Then now with our axis labeled that way, we begin the first inequality. The first inequality whereby x is 100, 300. So 100, 300, that is the coordinate. Then 200, 200, this point, 300, 100, this point. So those are the coordinates for the first borderline. We can do it in blue. According to the nature of the inequality, we're supposed to use a complete borderline. A complete borderline. So the borderline is going to be complete. Yeah, that is the first borderline. The other borderline is now going to be the borderline 2 now. X equals to y, or y equals to x. Therefore, these are the coordinates. 50, 50, 100, 100, 150, 150, 200, 200. So now we do a line through there, but we're supposed to know that it's strictly greater than. Means the line is going to be dotted. So we do a dotted line. Allow me to change the ink. Do a dotted line. I'm making it in red. So a dotted line should pass there. So that is the dotted line that we intend to have. That is the dotted line. Yeah, it's supposed to be dotted. The third one, x equals to 300. So on the x-axis at 300, and it's a complete line. The nature of the inequality, it's supposed to be a complete line. So a complete line, x equals to 300, like that. Then another complete line, y equals to 8. Another complete line, because of this nature of inequality, y equals to 80, we make it complete. Making it complete now, point here. After 50, we talk of 60, 70, 80. Yeah, 60, 70, 80. Yeah, that is the line now. So we just identify the area which has been bordered by all the inequalities, and it is this region R. So the other parts now, we shed them. Being unwanted, we shed them. The other sides of the inequality now, the other sides of the borderlines are supposed to be dotted or shaded because we have identified the required sides already. We have identified the required sides, so the other side now we dot them. That is the region. It has already been represented. Remember, a student now who has chosen this question is already at 8 marks. 4 marks, 4 marks up here. We are remaining with the last 2 marks on maximization, part C. So the last marks now are saying this. Given that type G costs 500 per shirt and type B costs 300 per shirt, use the graph above to determine the number of shirts of each type that should be made to maximize the sales. To maximize the sales. So to make maximum sales, we're supposed to come up with what we call objective function. 500 type G, which is X, plus 300 type B, which is Y. They are giving us a certain profit or a certain sales equals to P. This one we call objective function. Objective function. Now with the objective function, we can come up with something that we call the search line. The search line. So for us to get the search line, now we need to say that the search line is having x-intercept equivalent to the coefficient of y, and it is also having a y-intercept equivalent to the coefficient of x. You just swap the coefficients for you to get the intercepts. So this is now the search line. It's the search line. And we can now come up with it, the search line. Again, according to the scale which has been chosen, 500 and 300 are going to be very large values. So we can even absorb these values by dividing uniformly by a constant like 10. So we can use 30 and 50 respectively instead of 350. So 30 and 50. That means 30 is going to be found here for the x-axis, and the 50 is going to be found here for the y. Then you do that line. We call it a search line. We do the search line. Let me change the color. I'm doing it in yellow. So the search line is going to pass here. That is going to be the search line. This one we will call the search line. The search line. Now with the search line, now we can slide a set square into the region until we see the last coordinate that we will come across, which is inside the region, and we will come across it, the last one. That will give us the maximum. I'm sure you cannot see my tools on the grid, but a student can work out that one now. Something else you're supposed to do is that this same combination of types of charts can be obtained using what we call, the inspection method. So with the inspection method, a learner can simply come to the region and they identify, because we are saying the region, all these are possible combinations of the types of the charts. But now the maximum cells is coming from 500, which is type GX, and 300 for type Y. Therefore, when X has the highest number, we are likely to have more cells. So we go to the largest coordinate, the largest possible coordinate of X within the required region. So the largest coordinate of X is 300. So for X, we first stand at 300 because it is the largest possible number of shards which are within the required region for X, and X is the one giving us maximum profit. We stand at 300. Now, when we stand at 300, according to the region, now we are supposed to look at the several combinations of X using 300. 300 can be with, according to the final coordinates here, it can be with 80, it can be with 90, and 300 can be with 100. Therefore, if 300 is with 80, 300 can also be with 90, 300 can also be 100. Then it means the highest number can be gotten when the value of y is also the possible maximum accompanied to 300, and that is 100. Therefore, we will talk of x 300, y 100. So maximum cells now. Maximum cells are going to be 300, each going for 500, plus 100, each going for 300. This is going to be 15,000 plus 30, 150,000 plus 30,000. Yeah, 150,000 plus 30,000. 150,000 plus 30,000. This is going to give us 180,000. So the maximum cells is 180,000. So that is how we play along that question on maximization. Thank you so much for following. See you in the next lesson.